All right, so today, 1/9/19. All right, before we even start, we're doing bearing, okay? Now, when we do bearing, watch. On a compass, not a protractor, but on a compass, when we do bearing, north is 0 degrees. No, I think this will be easy if you just watch. North is 0 degrees, and on a compass, the compass that you navigate from, it rotates this direction. East is 90 degrees, south is 180 degrees, west is 270 degrees, and of course, back up to north at 360 degrees. Does that make sense? If you do a protractor, it's different. On a protractor, if we want to measure angles, then 0 degrees is here, and we measure our angles up that way, right? Just like we did on a world. Yeah, Cody?
Is 360 degrees north and 0 degrees north the same thing?
Yes, absolutely, yeah. So on a protractor, we would put our, we'd put our protractor then, we'd zero it out. You guys see the 0? We'd zero it out here, and we'd go 10, 20, 30, 40, all the way up to 90, right? But on bearing, and that's why I buy these circular ones, on bearing, we put north here at 0. See, I got the 0 up here, and then the numbers rotate 10, 20, 30, 40, okay? So it's just different. It's just different. It's how we read a compass. And you guys have all held a compass, I assume, and looked at a compass and how it reads. Okay, so let's take a look at this problem. Let's read it first. I've got to add something to this. This ship's going to go 8 knots. Please add that. Please add this. I need to put 8 knots in there. That was my error this morning. I'm not putting the 8 knots in. Okay. Now, let's take a journey. 2 ships leave port at the same time. Ship A travels at a bearing of north 25 east. Now watch my pencil. So the ship's going to point north, and then it's going to rotate 25 degrees towards the east. I'll do it again. Ship A is going to look north, and it's going to rotate 25 degrees towards the east. Okay, and we'll draw that in real soon. Okay. Ship B is going to look south. It's going to look south. Okay, and it's going to rotate then 40 degrees towards the east. So it's going to go that direction. Does that make sense? So when I do this, both ships are going to look at their compass. So the first thing I'm going to do on my paper is to put what I call my compass rose. I'm going to put my compass rose down here. Here's my north, east, south, west. Okay?
That end looks like a W.
Yeah, sure does, doesn't it? So let's have port be right there. Okay, there's my port. That's where boats are going to start. So let's go ship A. Ship A is going to go ahead and look north. So I put my protractor up at north, so 0 degrees, right? And I'm going to rotate 25 degrees, 10, 25 degrees toward the east. Okay? So I took my protractor and I went 10, 25 degrees towards the east, and I'm going to draw this 12 knots. So I'm going to take my ruler and draw this 12 knots. Put my ruler in, draw 12. It's a little bit off into my up to here. I could half it. I could totally half it. So here's boat A up here in the words. Okay, so 12 knots is 12. I know this angle's 25 degrees. Okay.
Wait, should we make it that small?
You could half it and call it 12. So I did my.
Your 2 lines are very small. Do we need them that small? Like, you made everything very small.
Well, this is just my compass.
So that's not important?
Not really. Just as long as I've got a bearing. Right? This is the line that's supported. Here's my ship. My ship's traveling at 12, okay? In this direction, okay? Ship B is going to look south. So I'm going to turn my protractor around. I've got 0 down here. Okay? I've got my 0. And I'm going to rotate 40 degrees towards the east, okay? 10, 20, 30, 40. So ship B is heading in this direction, okay? Ship B is heading in this direction. And it's going to go 8 knots, so I'll draw this 8. Okay. should be. This is 40 degrees, okay? And this is going to be my 8. Okay, scoot it up. How am I doing, okay? 40 degrees toward the east, 8 knots, okay? Now, the two boats are this far apart. And that's what we want to find is the distance between the two. But they're going to travel for 3 hours. So I've got two choices. I could either draw this 3 times as long, that'd be ridiculous, or I could just multiply this by 3. So we're going to go for 3 hours. So I multiply this by 3, I get 36. If I multiply this by 3, I get 24. So instead of drawing it 3 times as long, let's just multiply its magnitude by 3. And we get a 36 is my length now, and 24 is my length. Now, they are this far apart. I'm going to draw that in. Okay, that's how far apart they are. And that's what I need to find, is this length here.
What is the length of the item?
Okay, ready, Ben? This was 12, and I drew it.
12.
And then I multiplied it by 3. This one's 8, and I multiplied it by 3 because I'm on a 3-hour journey, right?
Yeah.
Now, how far apart are they? Well, I need to know this middle angle, okay? So let's find this middle angle. Here's how I'm going to find the middle angle, okay?
Easy.
Between north and east is 90 degrees, correct? This angle here has to be 65 degrees
That's facts.
because it makes a 90 degree. Between north and east, 90, right? This angle here has to be 50 degrees because between south and east is 9 degrees, right? So if I add the 2 degrees, I get 115 degrees, right? Here's what I know. I know side, angle, side. Side, angle, side. So I'm going to use the law of cosines. I'm going to use the one I gave you yesterday, law of cosines. So I'm going to start out. C squared equals 36 squared plus 24 squared minus 2 times 36 times 24 times the cosine of 115 degrees. Okay? Just setting up the law of cosines. Adjacent squared plus adjacent squared minus 2 times adjacent times adjacent times the cosine of the angle. Okay? I'm going to use my calculator to get that answer. Okay? Just type it in. I'm going to go 36 squared plus 24 squared minus 2 times 36. Yep, times 24 times cosine of 115. And I get an answer of about 2,602. So that C squared is 2,602.28. But that's C squared, right? So I square root, and I get an answer of about 51. And that's in terms of knots, which is like miles, okay? 1 knot is a little bit longer than a mile, about 1,000 feet longer, okay? No, I'm sorry, about 100 feet longer. Okay?
That's not bad one.
No, not too bad, you guys. Can you do that on Friday?
Hope so.
Okay. All right, let's turn the page. Okay, when you're ready, everybody got it? Now, in real life, there are people that do surveying. And when they do surveying, they have to use trigonometry to come up with the area of a plot of land. The government's going to tax you on how much land you have. So surveyors
Say you have
will...
a tree farm and you get a small tax break.
Right. So what we need to do is find out what the area this happens to be. So we have an area formula. Our area formula is 1/2 adjacent times adjacent times the sine of an angle. That's my area formula, okay?
We can find this.
Now, our dilemma is that we don't have a triangle, right? But we're going to make a triangle. In fact, we're going to make 2 triangles. So what I'm going to do is I'm going to take either, you guys watching? Boys watching? I'm either going to take and divide it here or here, okay? Does not matter. I'll do it this way because this way Varush has already started doing it. So I will cut, it doesn't matter which way you cut it. So I'm going to cut mine.
You need a knife. Pencils are not very efficient.
Yeah, I guess not. Okay. So what I've done now is I've created two triangles. You guys see them?
Not really a problem.
I've got triangle 1 and I've got triangle 2. Okay. So the first thing I do is let's make two triangles. So step 1. First, step 1.
It's not going to stop.
Let's find triangle 1, which I can because I've got my side, angle, side. I can find the area of triangle 1 pretty easily. It's just going to be my 1/2 adjacent times my adjacent times my sine of my angle. So I'm going to go 0.5 times 20 times 28 times the sine of 130. And I got an answer about 214.5.
Wait, and that's when you have side angle side?
Yes.
Use that?
Yep.
What was the other one we did? Just 'cause the other one was different, but didn't we have side angle side on that too?
Correct. So here's the differences in the question. The question is, this one we're finding area.
True. Got
There you
it.
go. I knew you would. Okay, so that's the area of triangle 1. I'm going to circle it because I'm going to come back to it. Does that make sense? So I've got triangle 1. Now we need to find triangle 2. Now here's our problem in triangle 2, Ben. Is we need, Ben, you watching? We need side, angle, side. And I don't have it. I've got only a side, don't I? So let's find the side first. Let's find C. So second, step 2, let's find the diagonal. Let's find C. We're going to find C. So we're going to use our law of cosines. So we're going to go, okay, I'm going to say C squared is equal to 28 squared plus 28 squared minus 2. Oops, I said that wrong. 20 squared, my bad. 20 squared plus 28 squared minus 2 times 20 times 28 times the cosine of 130 degrees. I'm going to use my calculator to get that answer. 20 squared plus 28 squared. Whoops, clear that. Hit the wrong button. Try again. 20 squared plus 28 squared minus 2 times 20 times 28 cosine of 130. And I get C squared is equal to 1,903.9 blah blah blah, but we'll square root it, right? Square root, because C squared. Okay. Square root. And I get an answer of about 43.6. Okay, now let me put that in my triangle because I want to come back and use that. So this side now is 43.6. Okay, got it? Okay, now I've got my side, but I don't have my angle. What I'm going to do is I'll call this theta. Everybody watching? Ben, you watching? If I can find theta, I really want this triangle. Let's call this theta, or I like this. Let's call this alpha. Don't let that symbol bother you, but I want that angle, okay? If I find this angle, subtract from 110, right? Find this angle, subtract from 110, and then I've got that angle, correct? So let's find theta. Now to find theta, I'm going to set up my opposites. Opposites. So I'm going to go, okay, step 3, I'm going to find theta. I'm going to go sine theta. Sine theta, thank you, Katie, over 20 equals sine of 130 over 43.6, right? Multiply up to 20, and I will sine inverse. I'll use my calculator. Multiply up to 20. 20 sine 130, close my parentheses, divided by 43.6, and then I'm going to sine inverse that, right? So I'm going to sine inverse that. Inverse my answer, and I get about 20.6. Okay, so that's this angle here, 20.6 degrees. Okay, now I can get angle alpha. You okay with the symbols? Okay, so the fourth thing is to find alpha. Now this actually doesn't seem too hard. This angle is 20.6. The entire angle is 110. Just subtract them, right? So alpha is going to be, in this case, my 110 minus my 20.6. And I get an answer about 89.4. Okay, I'm going to put that in here. So I'm going to put in my 89.4 now. Put in 89.4 degrees. And now I can do it because my sine formula, let me scoot it down real quickly, is 1/2 adjacent times adjacent sine of the angle, right? So now I can find the area of triangle 2. So fifth step, find area of triangle 2, which I'll go 1/2 times my 43.6 times my 25 times my sine of 89.4. And I'm just going to use my calculator, okay? 0.5 times 43.6 times 25 times the sine of 89.4. And I get about 545. About 545. Okay, and then that's in terms of centimeters squared. Now, what do you think the third step is? The last step is just to add the two triangles, right? Okay, so last step, add triangle 1 plus triangle 2 will give me the full plot, right? So I'm going to take my 20 points. Oh, no. I'm going to take my 214.5 plus my 545. And I get about 759.5 centimeters squared. Wow. Okay.
So many songs like this.
All right. Cooper,